So let's look at another example of a place where we would use strong induction. So let's suppose that my sequence A1, A2, A3 is a sequence defined as follows. So A1 is 1, A2 is 3, and AK is going to be AK minus 2 plus 2 AK minus 1 for each integer k that's at least 3. And we want to prove that AN is odd for every integer n that's at least 1. So to do this, we're going to have to stop and think about what it means for an integer to be odd. So maybe let's stop and recall, what does it mean for an integer to be odd? And we say an integer m is odd if it needs to be a multiple of 2 plus 1. So if m is 2 times an integer plus 1, where k is an integer. It's an element of z. Okay, so now that we have the definition of odd in our head, we're going to start proving this with strong induction. Here we need to use strong induction because we have 2 initial values here, so regular induction won't be enough. So let's do our basis step. So we're going to show that the first 2 numbers in this sequence are odd. So y, our first number, A1 is 1. Why is 1 odd? Because it's 2 times 0 plus 1. Okay, so A1 is odd. What about A2? 3. Why is 3 odd? It's 2 times 1 plus 1. So A1 and A2 are both odd. So the statement we're trying to prove, P1 and P2, is true. A1 is odd and A2 is odd. So that completes our basis step. Let's do our inductive step now. Let's let k be any integer with k needs to be greater than or equal to. What's our largest value from our basis step? It was 2. And we want to assume that AI is odd for each integer I with 1 less than or equal to I less than or equal to k. And so now we're going to identify what we need to do. So what do we need to do? We must show that AK plus 1 is odd. That's what we have to do. So we need to show that it's 2 times a number plus 1. All right, so what do I know about k? I know k is at least 2. So because k is at least 2, that means k plus 1 is at least 3. And because k plus 1 is at least 3, what I can do is use the recurrence formula. So this formula right here, I can use that for AK plus 1. So you're going to replace k by k plus 1. I'll just say replace k by k plus 1. Okay, so let's go back down here. So then we get ak plus 1. It's ak minus 1 plus 2 times ak. And so let's use, now we need to use our assumption. So what's our assumption? AI is odd when I is between 1 and k. So both of these two that I have here, I know that they're odd. So that tells me some information. We know ak minus 1 and a sub k are odd. So they have to be 2 times a number plus 1, 2 times an integer plus 1. So we can say that there exists integers m and n such that ak minus 1 is 2 times m plus 1, and ak is 2 times n plus 1. We don't know what m and n are. They're just some fixed numbers. So what we can do is plug these formulas that we have back into this equation here. So that tells us that ak plus 1, it's 2m plus 1 plus 2 times ak, which is 2n plus 1. We can distribute that 2 in that second group there. So 4n plus 2. And what I'm going to do is I'm going to rearrange stuff. I'm going to pull all the multiples of 2 to the front. So 2m, 4n, and 2. So plus 4n plus 2, and I still have that plus 1 at the end. And then all of these I can factor out a multiple of 2. M plus 2n plus 1. And so this is 2 times an integer plus 1. So since when I add integers and multiply integers together, I still get an integer. That means ak plus 1 is odd because it's 2 times an integer plus 1. And that completes our basis step, or sorry, our inductive step.